Good morning, everyone. Thank you for being here in the last day of the session, the training. Thank you for your patience. I'm sorry about my voice. It was not because of the beer, it's the air conditioning. This chapter is a review of a lot of things we were discussing during the last 2 days. Is how to optimize and how to be smart to do the best in your drilling and blasting procedures, in your process, so you can save money in the downstream operations, right? We'll discuss a little bit some tools, some records, and how to evaluate the blast and its consequences. Okay? The blasting affects all the downstream process, right? As we were discussing in these days. It's important for you to have all the blast data so you can understand how did you blast one bench and why the results happened. If you don't register what you do, how can you fix if there is a problem? Yeah, and people change from time to time in the mine, so it's important for the next blaster that comes to the mine that he understands what happened in the past, right? So he cannot repeat the same mistakes and always keep improving. So it's very important to register all the data, geometry, did you initiate the blast, what time did you use, the geology, and the results. A lot of mines have registers from the excavators. If it's not automatic, the operator can have notes. Take notes. Oh, this blast is very blocky. It's hard to dig. Or, oh, it's very soft, very easy. And the productivity. How many tons per hour did this operation achieved? The same for the trucks. How many tons did the truck transport per trip to go to the crusher? And the truck has a nominal capacity. You cannot pass this capacity too much. The manufacturers always says in their manuals, do not pass more than 10% or 20%. It's a limit not to damage the equipment. But you can be transporting less than the nominal capacity. So if you measure it, if you control, if you register these numbers, you can improve it. How can you improve the tons that a truck transports? Exactly. Better fragmentation. The much finer your blast outcome, the truck will transport more tons, right? Imagine if you put only big blocks. There will be a lot of voids between the blocks that could be filled with finer material. So the fragmentation has a direct impact in the loader productivity and in the truck's productivity. And how can you improve your plant throughput or your plant productivity? The same, right? Fragmentation. If it's a quarry operation, sometimes fines are not that good. You have to be more homogeneous material that you can sell it to the market. Some depending on the size of the final product, the price is higher. Some maybe fines don't have markets to sell, or you need to sell it in a lower price. So you can go back to the blast design and try to figure out how to generate less fines in the case of quarries, for example. In a case of metalliferous mine, or gold, copper, the much fines you produce here in the blasting will optimize your plant throughput, the mill throughput, the energy consumption, right? This is what we are talking about. You can try to find a balance. Sometimes the miners have a specific budget for drilling and blasting. It's very common. And other manager has the budget for loading, and the other manager has his budget for transporting. The mine needs to have an overall look at the whole process, so we can take a decision, okay, let's spend some more money here. It's the beginning of the process. The chain process starts here. If you mess with your blasting, there's nothing more to do. You need to spend money in the loading and transporting. Do secondary blasting. It will complicate the whole process. Productivity, it depends on what do you want, what do you require, what affects my efficiency, what are the bottlenecks. You need to ask these questions internally in your company to see, to have these answers, so you can take decisions. We talked about some of the requirements: dilution, problems with excavation, oversize, process. Check where is the bottleneck in your process, and then start improving the bottleneck. If the bottleneck here is oversized, start dealing with this problem. And then when you fix it, another problem will appear, will show up. And then you start focusing each bottleneck. It's very important to understand the rock. Once you know the objectives, get to know the rock. We saw in these last 2 days how the structure, the joints, the hardness affects blasting. Faults. Some rocks are more abrasive, so it will affect more the crusher, the milling process, the phase condition. If the rock is massive, homogeneous, and if you are blasting in an environmental sensitive location, right? Blast evaluation factors. Let's take a look. What do you need to control or need to know or take action before the blast, during the blast, and after the blast? What do you need to monitor? Let's start here. Before blasting, what the blasters need to know, need to control.
Surroundings. Your surroundings, like the geology, water on the planet, stuff like that.
Perfect. What else? What else? Do you need to know how the class design? Do you need to know the class design? The explosives you are going to use, the initiation systems, the geology, the geometry, how will you distribute the explosives on bench? During the blast, what can you monitor? What do you need to monitor? Timing. What else? Water. The initiation sequences, firing times. You can measure the VOD during the blast. Energy loss. Vibration. You can put the monitors in the places where you need to control vibrations. Air blast. Try not to break the windows in the surrounding houses. Oversize and fumes. Take a good control of this so you won't face any future problems. And after the blast, what can you monitor? Misfires. What about the results of the blast? What can you measure? Fragmentation, the heave, productivity, and you will be able to calculate the costs, the whole cost associated with the blasting. You can calculate it before the intended cost, but in the end of the day, during the process of loading explosives, maybe you'll find an extra hole, blocked hole, so we will need to recalculate the actual consumption of the products. And then you have the final cost. Is it okay for you to do in the field? Is it possible for you to do this in your quarry, in your mind? Yeah? Some tips. Before firing, there are some simple things that you can do. Take measure. I see that some mines in Latin America, the blaster don't measure the blast hole before start putting explosives, before start loading. So if you don't measure the depth of each blast hole, how can you know how many kilos of explosives we will put inside the hole? What about the stemming? Right? If the hole is blocked, you start putting the cartridge up, always blocked, and you will try to take it off, and maybe it's not possible anymore. So, simple things. Measure the blast designs, burden spacing with a tape. Very simple. And find out how many meters you are doing wrong. It's very common to find really mistakes on bench, burdens and spacings. Camera, video. It's not too expensive to buy a simple camera just to film the blast. For a quarry or for a mine, it's nothing, right? A simple camera can show the blasters if there is a fly rock, if the stemming is working properly, is confined with explosives. You see if material is going up, right? inclinometer to check if the drillers are putting the drill rig in the right angle, or even if the blast hole is correctly drilled. Theodolite, just to check. Normally the topography guys, they have this equipment, theodolite laser profiler, so you can check if the blast holes are located in the right position, if the burdens and spacings are correctly located. The laser profiler is a technology that you can scan the surface, the free face, for example, to check for any cavity. If you might face some fly rot from this cavity, if the burden is too close or too heavy, we say, that will generate problems for you during the blast. In-hole tools, mirror, thermal, if you face some rock that can react, or hot grounds. Simple tools that can help you a lot. They measure examples. This was the design. This was the plan. 2.5 meters burden, 3 meters spacing, 13 meter depth, 3 meters stemming. And then the blaster started measuring. And what it found was an average of 2.6 per tree, 12.6, 2. Not that bad, huh? Burden spacing. Depth in the average, okay. It's tolerable. This stemming is quite short than the plan. Maybe you had some problem of ejection. But the minimum burden, 2, minimum spacing, 1.4. So the pattern is very short. The holes are close to each other. The minimum depth of 8 meters. What could have happened in this blast hole? A toe. And the stemming 1.3. Wow. Rocks will be flying. And the maximum burden of 3.8 meters. Wow. What can happen in this blast hole? Very heavy burden. Oversized blocks. Maybe the explosive won't have energy enough to move the rock. 3.4 meter spacing. What happens with the blast, with the face? The wall, the spacing is too high. Maybe we generate a wall like this. 1.9 meters longer than the design. What is the implication here? Excessive breakage for the next bench. What else? A hole, for the bench, for the next bench. A toe here, a hole here. 1.9 meters of extra consumption of explosives. You are spending more money here, unnecessary. So, if you check your design after drill on bench, if you find things like that, don't look only in the average. The minimum and maximum can show you a lot of problems. 2 meters burden, fly rock, 1.4 meters spacing, too close. What can happen when a blast hole fires too close to another? Crush the other hole, damage the explosives, desensitize. This was actual measurement taken as an audit. Identify the toll. If you don't have sophisticated, computerized features or equipment, use it. Use this tool. Where's the toll? Is the burden in the toll too heavy? Before drilling, can we do something? How could we drill here? What could we do to fix it? If you drill from here in a vertical hole, what's the problem? Heavy burden in the toll. What could you do? Angle drilling, some short blast holes in the toll, which is not so recommended, but sometimes it's necessary. If you have a clinometer, try to figure out the angle. You may face some problems here. Fly rock, excessive energy, and pore fragmentation and those. Laser profiling, it's a scanner that reads a lot of points in the surface and creates a surface. So you can use it for you to mark out the blast holes here in the top edge according to the surface. You can change the angle for each blast hole if you are confident that the drilling will be good, right? If you need to have good control in the drilling process. Designing the drill pattern. Laser profile. It generates a profile like that. So here is the designed blast hole. And when you scan the free face, you generate a profile like this. So you can have, for example, in this example, every half meter, you see the burden. You check the burden. And you can put some colors to facilitate the view. The yellow shows a burden lower than the plan, and the blue ones shows burdens higher than the plan. What can you do in this case? You have a problem here, lower than the plan, and a problem here, higher than plan. What would you do? The blast hole was not drilled yet, so you have the opportunity to drill it properly. What would you do? Not right or wrong. Just like this. We are trying to figure out what to do in this case. Double loading?
Yes.
You put some intermediate stemming in the bottom, in the top, in the middle, where?
No, the bottom and the top.
You are loading already the blast hole. But before it, imagine you have not drilled the blast hole yet. So you can fix it. You can change something. You can change the color position. You can change the angle. Is it possible to do something in this case? You can put the hole a little bit further, increase the total burden. We will fix this issue, but this one is even worse, right? And then you can change the angle. So these two burdens, the average burden is more aligned with the design burden. Okay? You put a little back and more angle. Or if the hole is already drilled in that first position, you may use the stemming. In the region where the burden is too short, you don't put explosives. So you avoid the risk of fly rock. Right? But you need to know this before you start loading. Yeah? How to drill this? $15, 17 meters, 20 meters bench. What would you do? This is a possibility. It's similar to a ring in underground designs. If you are in a tunnel and the ore vein is above your head, you can drill rings. But look, in the top bench, when the blaster is here, he needs to know that the first blast hole, for him, this is the first row, right? This is the second, this is the third. But if he loads it at the first row, and this as the second row, and even after that for timing, to put the delays, you can make some mess here. Yeah? And the first one, you imagine this is the first blast hole, first row, you put the first timing, it will fire first and will damage this column. It's not common to see this practice. It's very complicated, but it's a possible solution. Toe holes. You need to be very careful when drilling and when blasting. It can be a gun, right? Really? For the miners to have a good drilling process, the miners need to understand the rock types and how it changes. Sometimes the drillers are drilling in an area and suddenly 5 meters to one side, the rock changes completely. Penetration rates. If the drilling have a good log, a good register, it will ease a lot the blaster's job. So you know that the rock types will change in 5 meters if the driller informs you, right? Cavities. Sometimes the drilling is performing the drill, and then it finds a cavity. It's important to register. deviations. If the mine asks the guys that are drilling, we need to speed up, we need a better production. Okay, the guy will speed up, but depending on the rock type and depending on the joints, the driller can find a joint and then the hole deviates in the direction of the joints. If a rock is too hard and it pushes the speed, the drill blast hole can be anywhere, can deviate. Jamming, joints, fallback, relocation. It's important to get all this information. There are some tools to monitor blast hole deviation. One of them is called bore track. With the bore track, you put an inclinometer, a sensor, it's a probe, and you go registering meter by meter, and it takes the front angle and the side angle. So in the end, you know in every meter the position of this probe. You can combine with the laser profiler, with the scanning on the free face, and you have information meter by meter. The real burden, not only the design burden. You have the actual burden. And then you have 0.1. At 1.2 meters, the burden was 2.7. At 0.2, in 3.4 meters, the burden was 2.7. And then you see, here, at 5.7 meters, the burden is 2.1 meters. Maybe we need to reduce the explosive charge here, in this region, right? There is an information here that the drill accuracy logging costs about 3 cents of dollar per ton. It depends on each country, right? But it's not that expensive, and you have a very good control of your loading process. During the blast, initiation sequence, firing times, explosive quality through VOD, burden movement, energy losses, vibration of glass, oversized fumes. All these you can measure or you can monitor. Some are visual, like fumes. You can film it to see oversize, to see energy losses through the stemming, burden movement. You can use the VOD measurement equipment, and you can check the blast designs for timing. With a camera you can check everything. Vibration and air blast. Sometimes it's also you need to measure it to deliver a report for the government or for the environmental entities. So you can always, in every blast, you register, you monitor the vibration and the air blast for safety, for environmental controls, legal requirements, efficiency. You can check with a vibration register if all the blasts fired properly, the timing, the correct timing. This is a typical VOD measurement. This is an old one. This is an old equipment to measure rock movement. You can use a simple camera also to measure the movement. Today, there are some technologies that you install in the excavators. This is a camera that films every time the loader excavates the mud pile. It measures it and take pictures, and immediately online tells you the fragmentation. And it creates the distribution curve, fragmentation curve. And if you face this profile and want to move from this direction, generating more fines, you can change your blast design, change explosives, change timing. Measurement, another way of measuring fragmentation is by taking pictures and using some softwares. You use an object as reference. Today there are some technologies that even don't demand the object. With the equipment, it already calculates the distance and the angle of the mud pile and automatically gives you the distribution curve. But you can do it in the software. Or in a software is called PowerSave. So you can take pictures as much as you want to process, and you measure different scenarios. Blast number 1 with a design pattern, a type of explosive, and you can change some parameter and measure again the other fragmentation distribution. Results. After the blast, what are you looking for? Fragmentation, heat, contamination, dilution, productivity, costs. It's very important to define all the KPIs, all the performance indicators that you want to measure in your operation. Sorry again. What do you look for? Wall stability, back brake is relevant for your operation. Mud pile shape, the power throw, the fragmentation, the vibration, the looseness for the excavator. What's important for you? The downstream effects, what are they? How do we find out? Is it diggability an issue? If you see a lot of trucks, a line of trucks waiting for the excavator, maybe you have a diggability problem. You need to check if the fleet is correctly calculated, if you have few excavators, but if the fleet is okay and you have a line of trucks waiting for the excavator, maybe you have a diggability problem. Check it out. The position of the excavator. Is it good? Where the truck might be positioned here. Hauling or transporting. Are the trucks transporting the right tons per trip, or less, or higher, that can damage the equipment, or too low that you are losing productivity? Is it a problem? Yeah, big one. Loader vision system for fragmentation, as we saw before. The camera measures the fragmentation instantaneously, online, real time. Crushing and processing. What's the ideal fragmentation for the crusher? The plant guys can tell you. What's the ideal fragmentation for the mill in a gold mine? The guys in the plant can tell you. They should. If you know that, you can take some actions in the blast. If you don't know, because they are your customers. Yeah? The crusher and the mill, they are your customers. You need to know what they need, so you can deliver better products for them. Analyze that data. The primary crusher, you may find it. Talk to the guys in the crushers and in the mill plant. Ask them for data, for productivity. How many tons per hour the crusher is producing. And take a look at that month by month, week by week, or blast by blast. If you know that one blast delivers more productivity to the crusher, okay, let's check it out. What we did different here that positively affected the productivity in the crusher. Let's repeat the blasts that delivered the higher productivities. And let's check why in these blasts or this month the productivity dropped. Did we change the blast design? Did we change the explosive type? Was the drilling performing well? And you need to be cost effective. In the end of the day, the quarry manager, the mine manager, they will ask you to be cost effective, so they can make profit, and so you can get your bonus. This is very interesting. In this axis you have the degree of fragmentation, the finer fragmentation, and the big boulders here, the size of the Toyota. Okay? So, if you need to improve your fragmentation and reduce it, of course your costs will go up. If you reduce the blast patterns, increase powder factor, use more energetic explosives, electronic detonators, your costs goes in this direction, okay? Right? But it helps the loading and hauling, the crushing and secondary blasting. If your fragmentation is that big, your costs to load and haul, to crush and secondary blasting are higher. But when the fragmentation is improving, the costs reduce to a point where the secondary blasting is not necessary anymore. Don't generate any oversize, any boulder here. But the crushing and the loading comes to a minimum, but drill and blast costs go to a maximum. So when you combine the total mine costs, this, you add this, and this, you have a total cost curve like this. So where's the minimum? Somewhere here. So, you need to design your blasts to deliver the fragmentation in this zone. So you can have a good drill blast cost, a small load and hauling, crushing, and maybe no secondary blasting costs. You need to find out this curve. For each operation it's different. You need to find yours. This is the typical cost distribution in a mine where there is milling process. Okay? So drilling is responsible for 11% of the cost, blasting 9%, loading and hauling 30%, crushing 5%, milling 35%, maintenance and overhead other 10%. So the big cost is milling. In general, because of the energy, the mills consume a lot of energy, and energy is expensive. In some countries more, some other less. But the milling cost typically is around 35, 40, 30%. And if you consider drilling and blasting costs, are the lowest costs probably in the mining process. So when you are preparing the budget, ask your managers, okay, let's work together to prepare the budget. Because every time the miners prepare budgets per activity and don't take an overall look of the costs. Maybe you are struggling here, reducing costs, and maybe some miners put this as an objective as a team for the drilling, for the blasting to reduce costs. But then the other operations will be very, very effective. Just remember this. Sabrex is not in use anymore. We use now the Shot Plus and the BDA that Victor discussed with you yesterday. So I won't pass. I guess that's it. Let me check. Yeah. Any questions, any comments, experiences in where you work? Please feel free to comment.
After a blast, when you fuel, how much time do you think that the blasting should go down?
To return to the area?
Yeah.
Normally, it takes 30 minutes so the fumes can go in some cases. If you see the blast, if you are in a position that you see the blast firing, you can return 10 minutes. Wait a little bit for the dust and for the fumes, and then you can go back. There are different procedures. In Brazil, for example, that we know a lot of customers, they have different procedures. Some allows you to return immediately. You saw the blast, okay, let's go. Go into the pickup truck and go to check if everything is okay. Others, okay, wait for 30 minutes. In underground operations, 30 minutes or more, because it's more difficult for the fumes to get out of the mine. But it's not a regulation.
How dangerous is the fuel?
I've never seen problems for health with the fumes. No record of any complaints for the fumes. If you see yellow or orange fumes, be careful. Wait for it to disperse in the atmosphere. But they are very toxic. The NOx family. Any other question? Okay. Your turn. Okay. Victor, you show one spreadsheet that we built that we use to calculate different scenarios. If we change explosive, if we change accessories, you can use the costs, the local costs for each product, and you check. You can expand the patterns to calculate the cost per ton. So it's easy. Some of you may have it in your computers, in your companies, but it's just an example of how we can calculate the cost per ton of a blast and compare it.
Hello everyone. I don't know if all of you can see it because of the letter, because of the size of the letters. But in this spreadsheet, basically what we do, we have all the prices, the product prices, as you can see here, all the costs, the final prices, listed in this tab. And what this simple spreadsheet does is simply doing the calculation, considering the type of explosives you're using, some information regarding the rock density, diameter, burden spacing, sub-drill, stamen size, and you can compare up to 3 scenarios. You can adjust your spreadsheet so you can compare more scenarios. But the idea here is just, for example, in this example, we are comparing one scenario with a burden, let's say 4.5 meters by 6. What happens if I change it to, let's say, 5 to 6.5 and 5.5 by 7? What will be the final cost? By using the same explosives, for instance. Where is it? Give me 1 second. It's very straightforward. Let's compare with the same explosives. So maybe we can change it later. So what do you think? It's going to be cheaper or expensive if we expand your pattern using the same parameters? It's going to be cheaper or expensive? Well, it's all in Portuguese, but I think it's pretty easy to understand. Let me check something. Okay. All right, that's why. Let's say we have a stemming of 4 meters. Now it's right. So it's not cheating. Alright. That's why in the first scenario we are using just the non-electrics. In the other two scenarios we are using iPad. So we can change it. It's just the same. It's pretty easy. It helps when you want to change the type of explosive you're using, or when you have to change the size of your drill pattern. You can use this sort of spreadsheet to calculate how it's going to be the final price. Something's happening in this one, the G column. I don't know. I have to check it out. So here's just for you to have an idea what is the impact of increasing your drill pattern from, let's say, from 4.5 by 6 to 5 by 6.5. So your final cost, all the numbers, all the figures are in reais. But in terms of comparison, there's no big difference. So it goes from 1.67, let's say, reais per tons, and to 1.39 reais per ton. So it's a huge difference.
The exchange rate divide by 3, and you have the calculations in US dollars.
So it's just a tool to give an explanation of how the expanding your partner might affect your final costs. Just one thing you have to analyze. Of course, you have to take into account all the fragmentation, how your fragmentation is going to affect your loading mole and your crushing and milling. It's just one thing. If you can get your drill pattern expanded and still keep your fragmentation, it's a good sign, dollar sign in this. Alright. It's pretty easy. Maybe we can share with you this spreadsheet as well for those ones who want. Yeah, we can have a talk after this session. Okay.
I rather suspect that the graph, if you were to do a graph on cost against expanding the pattern, would look something like this. In that, there would be an optimum area cost at the best, the lowest, and at the best coinciding with the pattern. That's the graph in the red. I rather suspect it would look like that. But as you go to the right of the pattern, where you're expanding, you have problems with the fragmentation and so on. And if you come to the left, you're using too much explosives, so you get a lot of time. So I rather suspect it would look like the red line.
Yeah, well, as we said, as long as you can keep your fragmentation the same or improving your fragmentation, you can expand your pattern. If you expand your pattern and you get a poor fragmentation, maybe that's not the way. And how can we get that? Maybe using electronic detonators, for example, drill patterns to check if is there any room to expand according to all the rule of thumbs, checking if your burden and spacing are okay with the type of rock you're blasting. There are several things you can do by changing your timing. I don't know. We have to check on the field. Probably in every mine site we go, there's always room to improve your fragmentation or expand your pattern. And sometimes you can do both. Alright? Okay. So we have 30 minutes to break. Okay. All right. So in this session, we'll be discussing about environmental management. Just give me 1 second. All right. Stand around. I'll change a little bit. I'll stay here. Get easy. All right. So, any ideas? What would be those environmental management? What are we talking about when we are saying environmental? What are they? Any idea? Okay, could be. But for this training, we're going to be focused on 3 things: air blast, ground vibration, and fly roll. There are several other things you have to be careful about. Pollution could be one, or environmental impact related to a mining operation. Okay. So that we're going to be trying to cover all those three points over here. But as we do not have enough
just a
time.
question. Sorry to interrupt you. Are there any issues working in sulfidic ores? Would you repeat this? Are there any issues working in mines where there are a lot of sulfide presence?
Yeah, there's a lot of issues when you're working with sulfides, especially if you get, what is the name? Acid rain. Okay? It's not that common like in Brazil, but it is a big issue. There are some laws, specific laws, to take care of this kind of procedures or techniques. That's a big thing.
There is an underground mine in Brazil, Caraíba. Is a copper chromium mine, and we have some cases of reaction of the sulfides in the rock with the handful. You saw that the product started to decompose, and then we analyzed the rock, and there is a risk in some tunnels for reactive ground. So you need to take care and always be aware of reaction. Depending on the type of explosive, if you are using package, it's protected by the plastic film. But if you are using bulk products, take a look at if there is some reaction. If the temperature is going up, if you smell something different, and if it is the case, take samples of the rock and send us so we can analyze in our laboratory.
Is it a big problem around here? A drain of acid rain? Is it a problem in the end in mining operation? No, acid rain?
It's not a problem. There are sulfides present in the rock model, but not to the extent that it creates the problem.
Thank you. Alright, so let's get back to those 3 points over here. As I was saying, you won't get too deep in those in the physics behind it, as we do not have enough time to discuss it. It's not the objective of this presentation. The idea here is just to give you guys a better understanding about what are the things that might cause a big vibration, big air blast or fly loss. That's the main objective of this chart. Okay? Alright, so why bother? Why control environmentals? Any ideas? Why would you bother? Preventing injuries. Yeah, that's a good point. Here there are some points. Some countries, for example, we have one big iron ore mine which operates pretty close to the community, let's say 100 meters close, the closest point, and we drill and blast close to the city. And all the citizens from the city, they have the power to interrupt the production if they feel like some of the ground vibration are disturbing them. So there are a committee that decides if what is the vibration level they are willing to what would be the word? Vibration level that they accept as acceptable. And of course, there are some regulations regarding all the damage to structures and the damage itself. For example, if you're having big loss that is not controlled, you might get some broken glasses, some cracks in the neighborhood houses. And of course, safety. Safety. That's the most important thing. And as I was saying, in some cases, we have an operating restrictions in which the community might be involved. And of course, the operating life, in some cases, if the authorities might give you some conditions to operate. If you do not meet them, you might have to shut down the operation. And of course, the efficiency and costs. And what I mean by efficiency, as we're going to see in the next slides, in some cases, when your ground vibration is too high, you might affect your wall stability. So if we have an operating restrictions in which the community might be involved. And of course, the operating line, in some cases, if the authorities might give you some conditions to operate, if you do not meet them, you might have to shut down the operation. And of course, efficiency and costs. And what I mean by efficiency, as we're going to see in the next slides, in some cases, when your ground vibration is too high, you might affect your wall stability. So if you do not take care of how much you're damaging your walls, you might have a wall collapse, for example. And that's a huge dollar sign in this one. Alright? And of course, careful orders and good corporate citizens. For example, they have another big gold mine in Brazil. It operates really close to the city. And the closest houses to this mine belongs to politicians with some big shops in the city. So you can think, alright, maybe it's a good thing to have a good relationship with them. It's pretty common. I don't know, maybe when they see a mine site getting placed somewhere, they think, oh, they will buy this area here in the future. It can sell it to them for a very good price. I don't know, maybe. Alright, so we are going to be talking about vibrations. As we said before, there are so many physics behind it, and I wish we had enough time to talk about it. But here, we are not going to cover all the different types of waves and how they propagate through the raw mass. For those who are interested to know a little bit more about it, just come ask me. Maybe we can share some files with some. And I think in the book in front of you, you can find some more information as well. All right. So here are one example of a simple vibration wave. In this picture, what we are illustrating here is if one single glass ball, that's the sort of wave you would expect to have. It's not as beautiful as this one. This one's just to illustrate. Okay? Just to illustrate what we aim to show you some of the terminologies when you're analyzing some seismograms. So in the seismograms, we are going to be analyzing the amplitude, the particle motion, which is related to particle motion, the frequency, the amplitude decay. It happens when you're getting further from your glass. So normally your amplitude decays. And here are some figures related to how fast your waves travel through the rockets. Okay? Alright. So, as we said in the previous slide, this was one sort of wave you might get from blasting a single glass ball. And what if we blast a second glass ball displaced from a certain amount of time? We would have sort of waves, considering they have the same shape, but they were detonated at different times. So, what do you think could happen around here? You would have a reinforcement of this amplitude. They would be added, isn't it? And what about if we fire a third blast ball? That's the sort of thing you would have. But it's not always this beautiful to see seismogram. Something more like this. So in this situation here, probably we would have a interaction between the hole 1 and hole 2 and the same around here. So this is just to give you an idea how firing different glass balls at different times might get you a different reinforcements. And that there are several models, mathematical calculations you can do to minimize this sort of reinforcements. Okay? Alright, so in this picture, this is a typical seismogram we get from a glass ball. It's not as beautiful as the other one, so this is a typical one. So what do you think would happen if we fire a second one? 80 milliseconds apart. So this is the sort of graph you would get. we will have a vibration reinforcement in this situation. And what if the holes are velocity 20 milliseconds apart? You think you would have the same situation? Would be reinforced? No, exactly. So these are the things you probably would get in our recycling rate. Okay? But remember, this is just an example. Just an example. You could get the same thing sometimes like this, using the same time, 8 milliseconds. You have to measure in your mindset. If we have time, I'll show you some pictures how we do that. Alright, that's a very interesting picture. So, in your opinion, what would be milliseconds? What is the paper using milliseconds delays? Let's say, for instance, if we are finding a big blast, all blast holes at the same time. Let's say this is the sort of effect we would get. Let's say 100 kilo rock. When you drop it in the water, you can have a big wave that attenuates when it gets further from the source, which is this rock. Okay? So, and what if we get the same rock and breaks it in 100 tiny little pieces? What sort of waves do you think we would get? Bigger or lower? Smaller. Yeah, that's it. It's the sort of things. That's one way of explaining what the milliseconds delays do. So you would have the same amount of rock, 100 kilos per year, but different shapes and size of waveforms. Okay, so here are another picture, very interesting as well, that shows when you fire a blast door, the blast, when this blast hole, this picture illustrates some different wave shapes you can get depending on your location. If you're in the surface, inside the rock mass, and inside the canal. In your opinion, which one is the worst in terms of damage? The low frequency or the high frequency? It is. Yesterday, I don't know if you remember, Andrea was showing a picture of a ship in the sea when it hits very tiny and lots of waves, and the ship stays pretty much the same in the same position. And when it hits a big wave. What are the differences? These are the smaller and faster waves, and this one is the low, is higher. So this one is what we always try to avoid when we are blasting. Low frequencies. Alright? Because they are responsible for damaging structures, most of them. And how they can get to your structure. In this case here, we have a house. They might go straight through the rock mass. They travel through the surface. There are several types of waves: P waves, S waves, RA waves. We could spend all day long talking about them. But in summary, we have some waves that travel inside the rock mass, the surface, and some are reflected. You know, what are the implications of these reflected waves? I'll explain it today. Here's just another example. How you can measure and write down some vibration graphics. Okay? And what does this picture say? it's saying for some different distance. For example, here's our blast in this circle or circle size shape. You will have the same vibration, let's say 10 milliseconds, and once you go a little bit further, in all this area you're gonna get 5 milliseconds, 5 millimeters per second, sorry, and 2 millimeters per second. And this is the unit we use to describe vibration, millimeters per second, unless you guys using imperial units. I don't know, it's all around here or metrics. You use both. Okay. So, we are talking about millimeters per second, but how can we compare it to something more touchable? Or we can, for example, what would be the vibration caused by someone walking around 1 millimeter per second? And what would be the noise? How loud? In terms of, I don't know how to pronounce it. Decibels. Pretty interesting. Obviously, some people probably, I'm a short guy, probably know how it causes less vibration. Some other people will cause more vibration. And like the bread.
Well, it causes more vibration.
Probably will be somewhere around here. And here some other examples. What is acceptable? Jumping. When you jump, probably you can get a vibration of around 5. And same of how loud you're jumping, you might get 110 decibels. And this is something worrying. When your blast or when some noise or vibration can cause some, let's say, when it's not too comfortable to feel, which is worrying, will be around 10 millimeters per second. That's the human perception, all right? Of course, it varies from person to person. And what about structure effects? What would be safe? 10 millimeters per second, safe, or mirror, might. Would be a hammer, nail, something. Hitting a hammer or something on a table, for example, you would get 20 millimeters per second. What would be worrying? They break windows, for example, for instance, be something around 50 millimeters per second. But there is another thing we need to take into account, which is the frequency. That's just one thing we have to think. Frequency is something important. So the higher the frequency, the higher your particle velocity, or this millimeter per second can be. Alright? Alright, in some regulations, it varies from country to country. Again, you can get some 100% less than 10 millimeters per second, and some other 95% less than 5 millimeters per second. I'll show you some graphs in the next slides, showing all the regulations, all the standards, Australian standards, US standards, and Sweden's standards, if I'm not mistaken. In the German, they are the most common ones, in which you can see what would be the acceptable vibration in terms of TPD, which is peak particle velocity, and frequency in hertz. Here are some the Australian and New Zealand standards for comfort limits. As you can see, from the sensitive side, or for your neighbor who is very sensitive. There are some type of velocity that they recommend you to do with some external. And what would be the peak particle velocity, or PPV, for at least 95% of the blast per year, and 10 millimeters per second maximum, unless agreement is written with the occupier that a higher limit may be applied. So as we said, this is human perception. It's very difficult to do. And why? Because it is a human perception. Sometimes your neighbor might be more sensitive than some other neighbors, some other neighborhood. And it's, well, there are few examples, like in Brazil, and for example, they have a channel, a phone number in which the community can ring to complain about vibrations. And sometimes they ring, even if the mine sites haven't lost anything. And they complain. Sometimes these mine sites, they have a target to have at least, let's say, 5 complaints at most by the end of the month. So some of these complaints are related to this sort of situation. They even had a boss fired, and the people keep calling, complaining about the boss. It's very hard to view the table like this. Very, very complicated. And of course, this is a very interesting graph. In this graph, how we define break. Are we right? Is that what?
Yeah, it's fine.
Yeah, we have time. Should we stop?
You can break now.
Alright, so before explaining this beautiful picture, let's go for a quick break. Alright, folks. Let's return. So, what break you were talking about? Some standards. This one is based on the human perception. But there are some models to predict that help you predict what is going to be your vibration. And this model, there are several models. This is just an example. Ideally, you can measure in your mind site and build a tailored model for your mind site. So you can predict what would be your PPV, or peak particle velocity, in terms of millimeters per second, in function of your scale distance. Does everyone know what scale distance means? Scale distance is when you have your distance, here we have a PPV form. It's just the distance divided by the square root of your charge weight. Your single fire charge weight. I mean, for example, if you're firing just one glass bolt, you're going to use the amount of kilos of explosive used in this one glass bolt. If you are fired 3 glass bolts, for instance, you're going to sum all the kilos for this glass, for these 3 glass bolts, and put here right here in your formula. At the same time. Maximum instantaneous charge. Okay? So, ideally, as I said, you can build this graph for each region of your mind site, or for For example, we have several different geology, different types of rocks or geologies. You can build one of these for each one. So it helps quite a lot. For example, if you have a big blast and you have a restriction about the maximum ppb, you can check in this graph and see for the distance or your scale distance you're planning to cost. What will be for the maximum ppb? What will be the maximum scale distance you can use? And in other words, what will be the maximum instantaneous charging you can use, or how much explosive you can use at the same time? It's quite handy, especially if you're working close to the city, for example, or if you have some structure protected in your mine site. For example, your crusher, your fuel plant, it's just of the office, for example, it's a pure example. Here, for those ones who never.
Just a quick question. The distance that you mentioned, is it the total depth of the blast holes in which charges are loaded that you use as the R value?
Well, it depends. If you're doing as I said, there are several different types of models. The ones for near field, the ones for far fields, for instance. But the one for near fields, there are a bunch of formulas that take into account the length of your charge and how far is from your point of monitoring.
Okay.
For the far field, you can just take an average distance.
Okay.
Right in the middle of your blast, for example.
Okay.
That should be enough.
So it's not just the length of the hole, it's modified by other factors.
Yes. Well, I have all these formulas right here which I can share with you. So this is what a seismograph looks like. In this example, the fire 1, 2, 3, 4, 5. There's a 5, 1, 6, 7, and the production loss. And this loss for what we were trying to do here is to build this model here. So in this case, we had 6, 7 blast holes fire. The difference with the 1,000 milliseconds difference in between them. As you can see, you can register exactly what is the wave shape for each blast hole, and then the production blast. So this is just to illustrate how a seismograph looks like, and what information we can get from each graph. Here, for example, for this one, we get a ppb on 30 something millimeters per second, and the frequency would be around 10, something around 10. That's just the two information we can get from the seismographs. All right, and how do we build this model? I won't go too deeper in this subject, but just to illustrate, we can get the thing is we have to get all your scale distance in ppb for several numbers of blasts. Once you get it, you can put it in a graph and build your curves for the different locations. So for example, if you're going to blast in the northern region of your mine, let's say this red line. So you have a restriction on 30 millimeters per second. You can check what is going to be your scale distance. It's pretty handy. Okay. All right. So, just to give you an idea about what would be the frequency for those different kind of operations according to its distance. Let's say for a construction site, in a distance of 100 meters, maybe you might get a frequency of 100 hertz. But remember, this is just a huge average. Huge average. That's the normal numbers we might get from those three different types of operation. For quarrying, as you can see, the frequencies are lower. That's the thing I want to show you. The difference in the frequency, which one is the highest one, the most, or the highest frequencies, we can find them normally in constructions, the middle ones in quarrying, the large open pits operations will be working somewhere around 30s, 40s. Okay? Oh, this is very nice video. But before playing it, have you heard about resonance? The word resonance and what it means. Everything in this world, as we know, there is a frequency of resonance, which means that we will vibrate and keep vibrating with a very specific stimulation. Let's say, in this case, in this bridge, when they built it, they haven't studied what was the resonance, or frequency resonance for this material, and what was the wind stimulation, what was the wind frequency. So, as long as the wind was blowing in the same frequency, it started stimulating this bridge until it collapsed. It's something very interesting to watch. Have a look. Let's see, please. Just give me 1 second. I have it.
Bridge collapsed in November 1940, 5 months after it opened. A strong wind pushed the bridge at exactly the right rhythm to set it moving.
Seems like a drunk man.
Became the bridge's natural frequency or being built.
Very interesting. All right, so this is what we call natural frequency. And what frequency do you think structures, buildings, what would be the frequency, the natural frequency for building structures arranged? Around 20 hertz. So that's what the frequency we always try to avoid when we are blasting. So we can avoid the natural frequency of these structures we have on site or in the neighborhood. Okay?
So are you saying that because the frequency was 20 hertz, the natural frequency was 20 hertz, and the wind was blowing at the frequency of 20 hertz, that there was a combination of the two frequencies that caused this manifestation of the sphere?
Yes. I'm not sure if it was exactly 20 hertz.
No,
just the range, around 20 hertz. But yes, that's one of the reasons. And some other examples, for example, most of you already seen a glass getting broken by sound. There's some videos on the internet. You can adjust the frequency of each sound until the glass starts to resonate and it breaks. It's pretty much the same thing. Okay? Alright. So, with all this information, some of countries developed a glass vibration frequency standards. What would be acceptable in terms of frequency and peak particle velocity. In this case, this is the Australian and New Zealand standards. Here are what frequency you can use or you can allow to your glass to create in terms of frequency and ppb for different types of constructions. I'm not quite sure which one. There are dotted ones buildings with a certain numbers of stories, and then this line here is just for normal houses. I'm not sure which ones which. But they are quite similar. For example, in this case, for a frequency of around, let's say, 5 hertz, you can, that's the maximum ppb you can get around 4. In this graph here is inches per second, or 4 inches per second. Around it, or less than 0.4 inches per second. Okay? So, if you already know what is your ppb, your maximum ppb, according to the kind of structure, your neighborhood, or you have your mine site, you can get back to this graph and check what is your maximum charge you can use. Alright? And that's the German. These are for 3 different types of constructions: houses, buildings, houses with a certain number of stories as well. Pretty much the same thing. They are the most restricted ones. Australian, German, there is a Swedish one. They are used as a reference for most of the countries. Alright, so let's start talking about the things we can do in order to control the vibration. In your opinion, would it make any difference if I fire this glass from 1 to 4 or 4 to 2 to 1? As you can see in this picture here, when I fire from 1 to 4, the frequency of the vibration here will be lower than on the back spot. Alright? As we can see here in this house. Okay? Here are just some figures to demonstrate in terms of PPV or peak particle velocity, what kind of damage you can get. Once again, it's just a guide. Right. When you have a PPV lower than 250 millimeters per second, you can create no new fracture in a good rock, in a good, very massive rock. In between 250 to 1,000, you start failure of poor rock and minor cracking and competent rock. So, in other words, you can start creating new cracks. And in between 1,000 to 2,500, you can start significant cracking your rock. And above it, a major rock failure. Probably you're gonna get this sort of PPV really close to the velocity. Okay? Here's an example. As we said before, one of the things why bother controlling it? So you can get a good wall control. So your final peak wall, for example, won't collapse. Here are some examples of how much explosive as a reference you should be using to avoid this sort of bigger PPVs. For example, if you use 150 kilos per delay at 20 meters, probably you can get a 500 millimeters per second. 1,000 kilos per delay at 50 meters will provide something around 550 millimeters per second. Once again, that's just a reference, only a reference. We can measure it on the field and the, not exactly that, but a very good approximation about how much kilos of explosives you can use close to your final wall in order to protect it. Alright, we've been talking about vibration and how do we measure it? We use geoforms. And here are a few examples of how do we bond them to the ground. Well, and I should say, this is pretty common to see all these not indicated procedures. It's pretty common to see around. So you think it's okay to place your geoforms freestanding on the ground? No. Of course no. So, and what about it? Use a spike on the bottom of it. It just let it freestanding. It's going to have a little bit more friction with the spikes, isn't it? But it doesn't work. Sandbags, no. Because all these sandbags, they have its inertia, it's heavy, it's going to have a bad influence on your readings. That's the most indicated way to do that. If you are placing your geoform on rock, use a what is the name of it? A little piece of plate, a steel plate, and bond it to the ground. Like this. Here's an example. What we normally do back in Brazil, we have a small steel plate, and there is a hole right in the middle of the geoform, and we can just glue it or bond it to the ground, to the rock, and then place on the top of it our geoform, and then we can get a really good reading. Okay? And what about soil? When you place your geoforms on soil, here are some very bad examples. Again, freestanding, the big no. Sandbag, big no as well. Spikes, you can use them with some precautions, but not like this. And what about pressing pit? This looks good, it's not good enough. That's the proper way to do that. you can create a hole on the ground, pretty much of the size of your geophone, and surround it with a compact soil, so it can act as one piece of paint. Okay? You always can use a block of concrete, for example. If you're going to do your monitoring every time in the same point, the same location, you can build one block of concrete, for example, and use it to place your geophone. All right, and after that, we've been talking about vibrations and monitors and everything. But in your opinion, if you want to protect this church and we have a blast really close to it, where do you think you would place our geophone? On the ground? On soil? In this place, in this area here, close to the church? On top of it, concrete? Or inside the church? Or in the very top of the tower? Which one do you think would be the best one? This one? This could be an option, but bear in mind, if you want to know the frequencies about this structure, which should put it only. So probably this one would be the best option. Inside the church is a good option as well, but it's always inconvenient. Probably priests won't let you do that. You're gonna do a big mess inside the church, gluing it on the ground. So in here, it's good enough. And why not here? Right on the top. Because there are some influences by this structure around here. Right here at the top, this tower is going to vibrate very differently from all the waves that travels from the glass up to this structure. Okay? So always remember, this is the best option. Alright, here are some points of controlling vibrations. The things. Okay. So 4 big things we have to bear in mind. First, condition of rock. Of course, rock condition plays a big role in terms of vibration. Phase damage, as we saw before. Whenever you have cavities, for example, or your burden is not exactly that one that you planned, this can influence your ground vibration. Burden, spacing, glass hole, angle, etc. Always control all these things here. Of course, charge per delay, hole diameter, explosive strength, explosives concentration, initiation. If you're working in a mine site in which vibration is a problem, always do hole by hole. If you can reduce your vibration by doing hole by hole. Delay intervals, varying directions. Remember, we saw one picture comparing the difference in between the vibration results when we change varying direction. Distance, monitor location. Is it at the site boundaries, or is it at the office or house in your neighborhood? Let's try to go a little bit quicker. These other subjects. We are short on time. Alright, air blast. It is important. It's so important as it is controlling your ground vibration. Here's just for you to have an idea the difference of the travel times. Usually, normally, the travel speed in which a shock wave travels through a rock mass is around 3,000 meters per second. when we are talking about air blast, we are talking about the sound speed. So it will be around 330 meters per second. Okay? So as you can see, it's around 1/10 of the speed of the ground vibration. So what it means that you're going to feel the vibration first in the ground, and then you're going to listen to the air blast. Okay? Just a quick table for you, so we can compare the difference between the time horizon. Okay? And how do you think does the temperature influence the air blast? Yes, it does. Whenever you have a temperature inversion, you can have this sort of situation in which the air blast is reflected in the clouds. And you might get the situation, the house closer to the glass do not complain, and the ones further will complain. They will complain. Okay? And what about the wind effects? Again, in Brazil we have some mines in which operate really close to the city. Equipment, I have no idea how to say in English, but it's a bag that whenever the wind blows, it shows you the wind direction. So when the wind is blowing towards the city, there's no glass. We have to wait until the wind changes its direction, and then we can blast. So we might end up having something like that. All the air blast is pushed towards the city. And what about the air blast contours? As we said, as we saw in the very same picture when we were talking about ground vibration, all these contours, they were spherical. They were almost spherical. And these ones, when we are talking about blast contours, they have a sort of egg shape. And here we can see how the air blast in terms of decibels varies according to the distance. Okay? Alright. Well, the air blast, the same as the ground vibration, has its standards and rules. Here is an example for the Australian standards. From Australian and overseas research, damage even of a cosmetic nature has not been found to occur at air blast levels below 133 decibels. But, as we said before, there are some human perceptions behind it that we have to be aware of. Okay? There's different limits for different kind of standards. Just an example regarding the Australian standards. I won't spend too much time on this one. And how do we control air blast? It's not that too different from controlling ground vibration. So, we have to pay attention to the confinement. I don't know if you guys remember yesterday we were talking about the number of roads we fire and the direction of the fragments might change. So does the air blast. So the confinement is something very important. We should be taking care about it. So exposed face area, front row burdens. So if you have a very large burden, probably you're gonna have a higher air blast. Standing type, standing length, burden, and spacing. Okay? And of course, as you can see, it's not that different from controlling ground vibration. Hole initiation, hole by hole, if you can always do that. Delays, interval, type of system of initiation here. For example, if you use a dead core on the surface, obviously it's going to produce more noise and more air blast than the non-electrics. Okay? And firing direction, as we said, time of firing, it is related to, for example, when the wind is blowing to one direction, you have to control and of course, the velocity ratio. If the velocity is too long, obviously the neighborhood will feel it more often. And charge weight, of course, the total charge of the bus, whole diameter, charge length. Now that's an interesting thing. What is the problem? Vibration can cause buildings to rattle, and air blast can cause structures to vibrate. So it's a little bit inverted, isn't it? So, for example, I don't know if some of you or most of you have the experience to be inside of a building. You just experience a air blast, so you can feel all the winds shaking, vibrating. And when you are inside a building, when you feel the vibrations passing through, it starts to do some noise. Okay? And of course you're going to feel the vibration. Fly rod. Alright. This one's a quick one. Just the things you have to be aware of, all the precautions have to be taken in order to avoid fly rods. Short stemming injection caused by the length of your stem, face cavities, breathing errors, deviation, as Andrea was saying before. Secondary shots, toe shots. Take care with them. Alright, and of course, insufficient delay and excess burden. And what can we do? Once again, hole by hole initiation, delay interval. Type of system. Again, if you're using dead boards in your column, you might damage your stemming, for instance. Confinement. Exposed face area, front row burdens, stemming length, stemming type and burden and spacing. And of course, charge weight, hole diameter, and charge distribution. As you can see, they are all similar for the three things. Do we have time for a quick video? Oh, alright, maybe 5 minutes. There we go. What causes fly rod? As we said, insufficient press burden. And how do we control? Here's an example. Just pay attention. Big blocks that will appear around here and here. And here's a control method. So adjust your stem. And what about when we have a mud scene? What can we do? I'm going to show an example. There's some different colors. Here, probably the energy escape through the weakest material, so we can use a decking to prevent it. Reduce burden like this one, or a cavity. Another example. You see this area here? Can you see? And again, what can we do to control it? bird. The control, of course, let's reduce the technique. And what about a cavity? You already saw something similar to it during these training sessions. Oh, that's a big book. It'll be short of time. Speed up a little bit. And again, try to visit that. Inadequate stemming. Did you see big fireball right on the top of the blossom? Of course, adjust your stemming. Right. Thank you. That's a microphone. Andrea.
Just a quick announcement. I'm going to pass around a list of names with the spelling and what you have given us. So you can just have a look at it. Put a tick next to the name to confirm that it's correctly spelled. And you don't have to be distracted from the lecture.
Okay, last chapter. Let's talk a little bit about regulation, storage, safety, and handling of the explosives and accessories. How to deal with misfires. And I'd like to show you one example that happened in last September in Brazil, in a big mine. The one that you saw the videos yesterday. We had an incident. And I want to show how we dealt with this problem. Okay? Short fire, storage, transport, causes of accidents, misfire, and recovery disposal of explosives. Also some examples of how to destroy it. Okay? We have here in the presentations some of the Australian standards, okay, or even an Australian company. So we try to use these standards as in all the countries, but every country and even in different states inside the country or different provinces, you may find different regulations. Okay. If you want, if you have the interest, take a look at this in the internet. It's very big, very large documents. the Australian standard for storage and use of explosives, storage and handling of oxidizing agents. We discussed it a little bit about the emotion. The emotion phase alone, when it's not sensitized, it's an oxidizer. The ammonium nitrate, not mixed with the fuel oil, it's an oxidizer. Okay? There are different rules for storage, transport, and handling oxidizing and explosives. Storage and handling of flammable and combustible liquids, risk management. So these are 4 of the documents that compose the Australian standards. Australian Code for Transport of Explosives by Road and Rail, Code of Practice, Australian Dangerous Goods Code. So you see that there are lots of documents, of protocols, regulations. State government acts and regulations, explosive mining. This is the Australian standard, AS 2187.2. It's from 2006. The use of explosives. Let's take a look at this. It's a statutory requirement under various mine and explosive acts that all persons working with explosives know the standards and procedures that apply to explosives. Major changes. So they are always constantly adjusting it to new technologies. If an accident unfortunately happened, we can learn with it and change some protocols, some procedures. So they included requirement for larger operations, adopt risk management, emphasizing planning, changing close proximity against a specific distance, removal of reference to approval by authorities, inclusion of requirements for an electronic and remote blasting. You see that a new technology, they needed to update the protocols. Changes to ground vibration and their blast assessment, like Peter presented some minutes ago. It depends, and it can be studied, and with new papers, with new scientists taking a look at this, the limits may change. Inclusion of new appendix covering exclusion zones. Maybe in Australia they were facing some fly rocks, or the opposite, no fly rock between the inside the exclusion zones, and they can reduce it, or they can expand the exclusion zones. And considering the atmospheric pressure, the regulations may change, may adjust. State regulations. A person may make application to the licensing authority for a license to store, manufacture, transport, import and export, sell and use. This is the shot fired license, right? In Brazil, for example, Oregon needs to have licenses to store. Who gives this license is the army, the Brazilian army, and also to manufacture, transport, import and export, and sell. And the use, the shot fire license in Brazil is the police that is the authority who applies the tests, the exams for the shot fires, and they fiscalize on the daily basis. On a mine site, any person using explosives shall hold a shot fire license you see that there are different regulations depending on the state inside Australia. And or be appointed as a shot fire by the manager. Or be working as a shot fire's assistant under constant and direct supervision of a shot fire. This works in Australia. Shot fire permits. To legally prepare and fire blasting explosives or fireworks, a person must have a current shot fire's permit. A shot fire must undertake an approved training course, master both the theory and practice of blasting, have knowledge of acts and regulations in relation to explosives, Australian standards, explosive local mine regulations that may differ from mine to mine. Have competency certificate not more than 3 years old. Specifically the state of Queensland in Australia. Demonstrate continuing need. Never blast if it may endanger any person's safety, health, or property. This is a rule for everyone, right? Special requirements for ammonium nitrate. Ammonium nitrate emulsion, when you see ANE in the books, in the manuals, it's ammonium nitrate emulsion, and AN is just the ammonium nitrate in the pure form. Is UN classification 5.1 oxidizing agent for transport purposes. The future, we don't know. And it may change from country to country. This applies to Brazil also. But is increasingly classified as explosive by the inspector rules. By the inspector, rules are changing currently. So, it depends from country to country. Licenses are required for manufacture, sale, storage, and possession. Recently in Brazil, I'll give always examples about Brazil, right? We have more experience over there. We had some issues with robbery in the magazines. They used to steal small diameter packed emulsion and detonators from the magazines in small quarries, and they blast the ATM. I used to joke that it's an expansion. The market is expanding, but it's very dangerous. It's a risk, and the Brazilian army that regulates it. They needed to take some action, right? They need to change something, and for the transport, they they changed the local laws. So that every truck that transport, it was not a regulation 2 years ago, but now every truck that leaves the plant in every manufacturer has to be a policeman in a car together, right? It wasn't necessary by law 2 years ago, and they changed it due to this kind of robberies.
The classification of explosive one, that's according to which standards?
This is the UN classification.
Of ammonium nitrate?
5.1.
Ammonium nitrate emulsion is classified as an oxidizing agent.
Yes, if it's not sensitized yet.
And if it's sensitized?
It's 1.
And what do you mean by sensitized?
If the emulsion contains microballoons glass microballoons, or if it's already chemically gasified. Okay? In Brazil, we transport the emotion without any sensitizer, so we can transport using this classification. An oxidizing agent don't demand the police to be together with the trucks. But if you have any product, any explosive product, family 1 means explosives and detonators. 1.1 is the explosive, 1.5 is the detonators. Death cords, boosters, they are all explosives.
And those are the UN classifications.
Yes. Okay. And the regulations are slightly different. When we transport emotion, for example, from our plant to a bulk site in a customer, where we have the tanks, the trucks, and the crew, we transport, if we are only transporting bulk emotion, AME, we transport as an oxidizing agent. And we separate from other trucks to transport the other explosives, the package emotion, boosters, death cords, and accessories, the detonators. Now you tell me, what are the potential hazards associated with storage of explosives? Some of you already worked in go inside magazines, for example, to take the explosives and go to the bench. Which risks or which hazards do you see? They are mixed together here, and maybe not, maybe good to be separated. Yeah. What else?
No ventilation.
No ventilation. What else? Wooden box or steel box, or should be a wooden box or not? Should be, okay. Not metal.
Those point charges are on the ground at an inclined angle, and that will cause an extreme insulation potential.
Yeah. Mm-hmm. Sources of ignition, matches. You cannot go inside the magazine with matches or lighters, right? Sources of impact, tools, steel. You cannot go inside the magazine with metal tools. In the surroundings, flammable grass, other materials, other flammable materials. We had an incident in a book site close to São Paulo, where I live. There is an Orica magazine, and it's a very calm, remote area where the magazines are, and we saw a fire in the woods, and the fire was coming, and we needed to call the firefighters to act quickly before it comes to the magazines. Prohibited contacts, fuels, rubbish, other chemicals. For all chemical products, and including the explosives, there is a compatibility table, and you cannot mix certain products with explosives. Deteriorated explosives, detonators. In the past, did some of you work with nitroglycerin? Yeah. Very dangerous, huh? Yeah, headaches, heart problems. And the nitroglycerin, there is a process of exudation. Yeah? And the cartridge starts to sweat. And it can be accommodated in the floor inside the magazines. And it crystallizes. And it's really, really dangerous. If an object falls, it can detonate these crystals. Safe distance between magazines. From country to country, the regulations might change. The distance and the amount of explosive you can store can change. Dirt, grit, shoes, friction. Always be aware of when you are going inside the magazine that you are not using, you are using proper safety boots to not cause friction. In the magazines, it's common to have some metal parts. How do you say that? Earth. Yeah. So you can the current can be discharged. Lightning protection. By law, the magazines need to have lightning protection.
What about use of electronic devices on cell phones and so on?
Forbidden.
And you should not even enter the magazine as such.
Yeah, in Oregon it's a forbidden procedure. And you cannot, the magazines, it's not allowed to have lamps. It needs to be only natural source of light, the sunlight, and also for ventilation. Some open spaces so the wind can go inside.
One of the risks that I know that we have in Guyana is that the place heats up quite quickly. And the magazines that we use are those containers. Now, if you were to go in a container, you'll find that will be a hot place. So how is it that we're using this type of material for the magazines, but yet it's a clear hazard, clear risk?
Yeah.
So what should be the best practice there?
There are containers in Brazil also as magazines, but you need to create the windows. You need to build it. The container should be prepared with wood inside. Yeah,
but should there be a more specific criteria that specifies the ambient temperature within the magazine?
Yeah.
So whatever modification you make to the magazine, it should reach that standard of, let's say, 30 degrees or whatever the case may be.
Mm-hmm. There is, in Brazil, for example, the regulation is only for the humidity. The temperature is not an issue and is not regulated, but the humidity is, and if it's below a certain level, you need to do something or evacuate the area. You cannot go inside the magazine and manipulate the products if the humidity is lower than a certain level. But the temperature is not regulated.
It should.
Maybe. In the case of the explosives and the accessories, you may have some problems above 70 degrees Celsius. In the shock tubes, is the most affected product by temperature. It's so hard to find this kind of temperature. Maybe that's why there is no regulation for that. Storage requirements. Fire extinguishers, always outside the magazine. water availability. If there is a fire in the nearby, in the grass, in the woods, do not combat fire when it's in the product. Never. Never. If you see the explosives on fire, run. Yeah, it's true. I told you yesterday about an accident in our plant in 2004, right? 3 people died. And they died because they broke one procedure. This procedure. The plant a fire started during the manufacturing process of a package emulsion with aluminium, which is very dangerous. And they tried to combat the fire alone. This was not possible. Everyone left the building, went to a safety point. And then 3 guys from the brigade, the fire brigade, they went back. The supervisor of the plant and 2 other guys. And then the plant blew. So the procedure is, if there is fire in the explosive, run. Go to the safety point. Grab everybody. Let's get out of here. Damaged, deteriorated, old stock, it's dangerous. There are some procedures to destroy it. There are requirements to build magazines. How do you lock? Who holds the keys? Who is responsible to have the keys? Bullets fired, weatherproof magazines. And the personnel. It's all about responsibility, all about your attitude, your training. And if you do not use alcohol or drugs when using explosives, it's better for your life. Control and records, quantities, stock rotation, because sometimes, do you know the first in, first out theory? Yeah? When you put some boxes of package emulsion in the magazine, okay, the next blaster arrives, okay, I'll pick this one, it's easier for me. And the other sheet comes and the box goes in the front. And you have maybe in the end, in the bottom of the magazine, some old package, some old products that you will never use. And it will expire. Right? And have a good signing, warnings, fences. It wasn't necessary to have fences in Brazil 2 years ago. Because of that problem with robbery, the army changed the law. Okay, it's necessary to have fences in every magazine with cameras. Storage recommendations. For alcohol, many months. For this Advantage 1 month. Power gel bulk 1 month. But package, now it's Senatel, right? The Senatel products, the package emulsion, 18 to 24 months. Cool and dry, right? The boosters, 5 years. Detonating cords, 5 years. Non-electric detonators, if it's sealed, 4 years. If it's open, 1 year. You may take a look at the catalogs of the technical data sheet of each product, and it will show you the storage recommendations. Transport regulations. Fire extinguisher. What type? Depending on the product you are transporting, you need to use a different fire extinguisher. Check it out, the chemical data sheet. Which is the proper fire extinguisher to use with each type of product. protected from batteries, wiring, wooden or non-sparking floor, explosive signs, protect load from fire and sparks, vehicle never left unattended. We had a case, some journalists were filming one of the trucks that left our plant in Lorena. The guy stopped at home for lunch. And he left the truck open. Really? You imagine what happened with this guy, huh? No detonator with explosives unless separated by a solid wooden platform. In Brazil, we can use a truck and we can transport both, but if the detonators are inside a wooden box, we call it a solitary case, right? And in another solitary case, the explosives, you need to separate it for transporting. AN regarded as explosive if carried with explosives. So, if you put some AN together with packed emulsion, which is already an explosive, this is considered an explosive. Okay? Explosives disposal have an effective explosive waste disposal system. Take a look at that. It's a drawing, but it's a real case. In an underground mine, during an inspection, the inspector found things like that. Food, a battery, accidents, misfires. What do you think are common accidents? What are the main causes of accidents in mines or regarding explosives? Human mistakes, human errors. No respect to deal with the explosives. Yeah? They don't know what they are doing. Common causes. Careless about regulations. I don't care. Inadequate guarding. Taking insufficient cover. I always stay here 100 meters from the blast. Never happened. Fires, ignition. There is a huge accident. You can search in the internet. A huge accident in Mexico. A truck transporting ammonium nitrate, a big amount of ammonium nitrate, about 20 tons of AN, roll over the road. And because of the fuel, the oils, the tires, it started a small fire. The truck operator was so frightened that he left miles away. But the neighbors started coming to see what was going on. You roll over close to a city, and the curiosity, no one's here, the truck driver is not here. The fire was going more. And then it blew up. More than 30 people died. It creates like a meteor hole. Imagine 20 tons of AN exploding. Take a look at the internet. I think it was in 2006 or 7. Handling and charging practice are common causes of accidents. Misfires, impact, friction. Oh, you see a misfire. Okay, let's try to take it off the platform and recover it. Theft and abuse. Like I said, one of the robbers, there are cameras in the banks, and one of them tried to assemble the detonator in the back in motion in the ATM, and suddenly nothing left. Returning too soon after blasting is a big risk, and answering your question, it also depends on the product you are using. Do you know how do you start a blast? With a lighter or matches? How do you commonly start? Blast machine, electrical. It's not common to use that fuse, safety fuse. Sometimes, okay. There are some incidents with safety fuse burning too slow. The powder in the cable is hygroscopic, so it can absorb water, humidity, and when blasters ignite with a match, normally in 3 minutes, in 3 minutes, 1.2 meter cable will start the blast, and then you wait 5 minutes, 10 minutes, 15 minutes, 30 minutes. It's a misfire. I'll go there and check it out, and it initiates. Yeah, there are some accidents like this. So be careful when using the fuse. Okay. There are registered of 30 minutes delay for something that would initiate in 3 minutes. And also there is an incident, the blaster initiated and there was powder from outside the cable, and it immediately in 1 second, 2 seconds. Yeah. It's tragic. Be careful when moving about the site. Don't assume this guy saw you. I tried to find some videos of trucks passing over cars and pickups. It's amazing. The guy don't feel nothing. I'll get it. I think I'll film from here. Be careful with curious. Yeah? People may be fascinated about blasting. It's amazing to shoot a blast, to see a blast. It's awesome. But you need to take care and take care of the people. There are some firework incidents. I'll not go through these incidents in Victoria. There are a lot of incidents. In a slide that Victor presented, first, when there's a blast, first you perceive the vibrations, right? Then the sound, the air blast, and then the fly rock if it happens. 14, 15 seconds in 1 kilometer. So, if you are in a place, under a construction, under a concrete building, a safety position for people to stay during the blast. There are one or two records about people that felt the vibration and heard the blast, and then take a look, and the rock killed the people. Yeah. Wait 15 seconds, 30 seconds, 1 minute. Wait there. Don't be curious. Uh, 12 to 13 years ago, in a quarry in Brazil, very close to the city, we had a fly rock, and it hit my school. Lucky that wasn't time, was the shift changing. At lunchtime, the kids from the first period went out, and the children from the afternoon didn't arrive. So we were lucky. Be careful after a blast. Don't get too close to the crest. The rock here is so unstable that might fall. Don't try to make that pressure. I'll try to fix it. No. If you find it, there are some procedures which show if you find the detonating cord or the shock tube, it's better. You can refire. Air. Why not? It can throw fragments, rock fragments, and hitting the accessories, the detonators, the explosives. It can cause some friction. Not a good choice. The same here. Be careful when going with the equipment. And I think we did a lot of wrong things because I have examples, very bad examples. There are some incidents in quarries, in iron ore mines, that there was a misfire, but with non-electrics or dead parts, if you don't see, you don't know if something didn't work. And then the excavators hit right a booster with a detonator, and the detonator was alive. And it boom. Sometimes it hurts the operator. A lot of machines already has a bulletproof window, so the operator is a little bit more safe. But sometimes it can kill the operator. Right?
Yeah, I think I was going to ask a question with respect to that, where you have misfires, and there's no way that the operator can recognize it from the mobile. Sometimes the geological technician, when they have to walk through mobile, they might find it, right? You will find it. Sometimes you might see it.
Yeah.
But then sometimes, there's not much communication happening, because in a real sense, you find that the dispatcher will start to give instructions to the trucks to start going back into the pit. The superintendent of the mines might start giving instructions for the loaders to start digging. So, what is the communication framework that should be in place when, let's say, I want to know about the procedure that should be followed, because should there be some personnel, whether it's in geotech or the blast foreman who've got to go and inspect the mock pile to see if there's any misfires in terms of walking the pile with, right? I mean, that could be difficult as well, right? But is there some standard that should be followed?
Yeah. We started discussing this with our customers, and we started some programs training the operators of these equipment to see if to get to know the explosives and the accessories, so they can identify if they find this is a cartridge. Oh, this is similar to a detonating cord. It's red or it's green. We started training the operators to see if he finds anything unusual, and he has the right to stop immediately, and communicate the blaster immediately. This is a procedure in a lot of mines.
Yeah, but with the shock tube, right? Many times you can find the shock tube in the mock pile.
It's common to see some residuals because the shock tube in the stemming region will not be destroyed, right? The explosive will burn all the shock tube which is inside the explosive column, but in the stemming region there is no explosive, so the shock tube will not be consumed. And also the extra part of the shock tube that you use to connect. And if you are using surface connections with shock tube, they won't be destroyed, so you will see it. The important is during the excavation process, if you find a shock tube here where it was expected not to be consumed by the blast, by the explosive, you may be aware. Okay?
And there is another thing we normally do back in Brazil. Whenever you find, just like in the picture, residual shock tube, you can see and check a little bit of it and check if there any residual agent X, which is the product fire inside the shock tube. So if you do find, you can try to fire it back again. Check if it's still connected to the primer or to the explosive.
Yeah, if the operator needs to be familiar. That's why we are training not only the shot fires, the blasters, and the drilling crew. We are also training the machine operators, the excavators, the front loaders, to get to know visually, okay, this is a shock tube. If it's the stemming zone, okay, I'm not so concerned. I'll keep working. If in the bottom of the blast, if you find a shock tube, maybe alert the shot fire. In the case of electronic detonators, as you test it before blasting, you test the connectivity, the communication, and in the moment of fire, it registers if all detonators fire properly. Okay? But if you have a miscommunication in one detonator, for example, you can call the topography guys in this place here in the mud pile. Maybe we'll have a misfire. So the topography can mark out the location or the possible area where you have a booster and a detonator alive, and then the excavation needs to be very careful in this region. This is one of the advantage of the electronics, is to know if there is a misfire or not, and take control of it. How to deal with misfires? Any visible fire downlines? If yes, refire. Only if safe. You need to make a good risk assessment. If you find a shock tube with the aluminum silver material powder inside the tube, okay, maybe alive. Let's refire. Only if it's safe. Isolate the area and check the possibility of a fly rock. And maybe double the area to put the people more far away. If there is no visible on fire downlines, remove stemming and expose charge. We did some of this when we know about a blast hole that had a misfire, and the excavator starts excavating the stemming. You can use manual excavation, but depending on the length of the stemming, it's not possible. The excavators, until you find the shock tube or the wires, okay? And then, if it's safe to reprime and fire, refire. If it's not safe, are you able to wash out the explosives? Use water. If yes, is it safe to recharge and fire? Refire. If you are not able to wash out, is it safe to dig out around this fire? Around the blast hole? If yes, carefully excavate. If not, is it safe to drill near a misfire to blast it out? Yes, drill near misfire. But it should be the last option, always. It's very dangerous to drill near to a misfire. You never know if there is a deviation. Okay?
What do you consider near?
Near. Good question. Good question. It depends on the hole diameter, because in a quarry, in smaller diameters, your burden and spacing are smaller. So near can be half a spacing or half a burden, right? Half the size of the burden or half the size of the spacing. And the near will be bigger in bigger diameters, right? In gold mines, in iron ore mines, with 9 inches, 12 inches. The advantage is that the hole deviation for the bigger diameters are smaller than the hole deviation in smaller diameters. Yeah? If you have the historical of deviation in your mind, you can drill a little bit far for safety, or put a lot of 3-4 blast holes around this area, far away, to be sure that you will not hit any live explosive, and then you fire all together, just to damage or initiate the misfire. But it should be your last option. Try the other options first. And here, the Australians have rules for that. In Brazil, there is no rule for that. Or controlled burning by authorized person. But it's quite dangerous depending on the amount. Always spread it in the field and before burning. Emulsion explosives. If the cartridge is very hard or very soft or beyond use by date, destroy by detonation within a large blast hole charge. Use it bit by bit load the hole normally, leave stemming a little bit higher than normal, and put the damaged package to get the height of the stemming, and then stem it, and it will be destroyed by the detonation. It's the best way of doing it for safety. At a suitable location, you can try to initiate it. Even if it's out of date, it might detonate, right? Don't trust just because it's out of date, it won't work. At a suitable location, in Brazil, the army, the regulations, it's called R105. You can take a look at the internet, the rules for everything in Brazil. And there is the distance and how to proceed with this. You can use the quarry in a time where with no production, isolated, and fire one by one within a safety distance. Burning, also approved by the regulations. That cords may be wet, bruised, damaged, the covering may be damaged. You can detonate within a hole, is the best way, or in a surface, air blast, or burn, not on the reel. And also, if you are initiating it in the surface, it's better to, how do you say it in English, unreel? And put the line, and then initiate the line, not on the reel. Safety fused, may be damaged, wet, aged, destroyed by burning. Do not burn Pentax, the boosters. Do not burn it. The procedure is to destroy inside the holes in another blast. Destruction of detonators, problems, dents, corrosion, painting, damage, pinholes, splitting lead wires, tubing, beyond date, lost number tag. If it's electrical, remove wires, tubing, or if a shock tube, by cut, no force. Do not cut too close to the detonator. Leave half a meter, 30 centimeters from the detonator. You cut here. Use the proper tool to cut it, right? Do not force. And then you can detonate it in the blast holes. It's the best way always. And maybe detonated by fire or initiated. You can put a dead cord, a new dead cord here, and initiate a dead cord, and it will destroy the charges. Okay? Don't burn. Anyone have experience of dangerous situations? I told some. If you want to share. Or during the lunch. You want to share?
My goodness. Oh, we were destroyed. It's a few boxes, about 60 to 70 boxes of it. What we did, what I did, is to blow the acoustic cover and place it in fire, the board. Now, what I was told by the security, which is the police, he's doing what we said. He will send the magazine, he will send the electricity. As he said it to me, I packed him in the fire support. Then he sends out the car. But before we go here, I let them know that the only thing you want there is the power box just got explosive. Russians. So to get there with the car, the upper cutlass and start chopping his foot. So the minority put it, I said, it is safe because the car shouldn't go with the powder. Even if I like it, it shouldn't go up. So I did like it. The fire was there, the fire was here. So I was watching the fire going, and I moved from here. After it started to burn, I noticed a strange thing in the fire. So I moved from here, come a bit closer to find out what is going on here, what is in that fire. As I move closer to it, I see what it is. I see the connector. So I decide to move away from it. So that's one part, like. So I did like this, right the other way, and that was it. About 300 meters away from here, I was picked up. And went off right here, and what I can hear is sound in my ears. I was lying here all the time. Hear someone right here. Come on, give me a few steps. He asked if I can see, if I know what to do. Many tables we have here. I didn't know why I didn't answer, but I just couldn't answer. And wait a couple more times, do this thing, and I said, okay, this guy here. He said, okay, he's all right. But the thing about the whole story is that I did not do the wrong thing. The people who sent me explosive officer, it is the police sergeant. I always keep trusting the police sergeant with it. He sent this explosive out. These guys were packed in the car. The car, there was so much of car, there was loose stuff. I couldn't leave the car. So I didn't see it. When I see it, I couldn't leave them. When I get back to see what that explosion did to the ground, it opened up straight in the ground, about 12 feet deep, and then wide. If anybody knows where it's Kukwani, and we went like Judy, the people like Judy could tell you the explosion from Kukwani.
Don't call it Judy though.
And now, whether it's small, whether it's just done, you know what the company told me? It's not even what they can do. You have to pay off from
Thank you. You are a very lucky man. Yeah. You are living your second life. Guys, that's it. That's it for now. I appreciate your timing, sharing the experience, discussing a lot about all the subjects. If there is anything else you want to know, any curiosity, any questions that may not be answered so far, please, the time is now. And I also want to remind for those who will apply to the exam, we will have a session after lunch. And for the others, I thank you very much for your patience and for your presence here. Thank you.
Very much.